Now that we've attached the legs, the next step is to level the platform. And the way we're going to do that is we're going to use these feet that have a screw thread on them, and then that's going to allow us to do two things. One, it allows you to bring the entire platform up and down if you want to. And the other thing it allows you to do is to independently change the length of the distance from here to the ground. And what that allows you to do is to level the instrument in the field. The way these work is that there is a lock nut on the top, and that's an 11/16 nut. And what you want to do, first thing you want to do is to loosen that nut. And by doing that, that allows the thread of the foot pad to move. So you're able to make it longer by rotating this way, or shorter. And there's a acorn nut in the top to help you in case it's kind of stiff. So that's how we're going to make these things higher and lower in order to do the leveling. And the way we're going to perform the leveling is that we're going to do it in 3 iterative steps. What you want to do is you want to place the level on the triangle collar. And what you'd like to do is to place it on this portion of the triangle collar. Do not level using the solar panel, because the solar panel is itself tilted. But the triangle collar is basically what is perpendicular to the shaft, and that's what we want to be parallel to the ground. And the way to do this is to take a small level, place it on one of the triangle collar vertices, but align the level with one of the legs so that the leg and the level are parallel. And what that'll allow you to do is, by looking at the bubble, to determine whether or not that leg that you're parallel with should go up or down. For example, in this case, the bubble shows that the leg that we're parallel with, which is this one, needs to come up a little bit in order to improve the level. So I'm going to go ahead over there, and I'm going to increase it while you watch the bubble. This is also useful to have 2 people doing this, because it allows you to have one person change the level of the leg and the other person let them know if they're almost there.
You're too high.
Overcompensated there.
A little bit more. A bit more, like 2 millimeters. Just a little bit more. Okay, so that's looking better. So
okay, so we've got a good level in this plane, and what we'll do is we'll just go ahead and rotate this to another leg, again casting the level parallel to one of the other legs. And what we see is that in this plane, in fact, this leg is quite low, the leg that we're parallel with. So what I'm going to do is I'm going to go ahead and raise this leg. We'll check to see if we're close.
no, you have quite a bit to go. More than that. Another 3 millimeters. Ah, 2 more millimeters, I would say. Okay, so now you're in the bubble.
Okay, so we'll keep going around. Now we'll go to the third leg. Line parallel with that. And that actually looks pretty good. I'm just going to lower it slightly.
A little bit more. A bit more. 4 turns maybe. Okay, that's in the center of the bubble.
Okay, and then we'll keep, now we have to do 1 full rotation to check to see that every plane is level. So we have to go up a little bit more on this side.
One more turn. Excellent.
Then we do the next leg. needs a little bit more. So I'm going to increase the height of this leg slightly.
A bit more. This one is mostly, you need probably a quarter of an inch, so 6 millimeters. That's good.
Keep going around. Okay, now I'm checking. This bubble looks very good. I check this leg. That looks very good. And I check the third leg again. And that looks very good. Okay, so that means that we're level on all planes. So what we've done now is we've leveled the instrument. There's one more thing we can do. If we wanted to, we could now increase the overall height of the platform up or down by rotating the same amount on each leg. So you can do, for example, 2 rotations on each leg, and the instrument will stay level, but the whole platform will go up and down. Okay, so once you're in place and you're level, one of the things that you're going to want to do is you'll certainly want to measure the height from the sensor to the ground, in most cases, but it might be certain instances where you would like to change the height from the sensor to the ground. So we'll go through a step-by-step procedure on how you would want to do that with this sensor. So there are 2 things that have to be done when you're changing the height of the sensor. Is you have to release the tension from the cord grips over here, which is basically the stainless steel screws. And then you want to slide the sensor up and down to the right location. And then you want to relocate the cord grips to a better spot. So let's say we want to make this shorter. We want to make the distance between here and the ground longer. I'll just go ahead and loosen the cord grip. What I'll even do is I'll remove the screw to make my life a little bit easier. So I've removed the screws and the clip. I'll put them on the side over here. And next, I loosen the 2 screws that are holding the sensor in place. So you don't have to remove them, just loosen them. Now that they're loose, this will slide up and down fairly easily. And what I'm going to do is I'm going to pretend that this is the perfect distance between the sensor and the ground. And I'm just going to tighten those screws, just like that. Now, one thing is that the cord grips now is too low for the sensor. The cord is above. So what we want to do is we want to move the entire cord grip higher. And to do that, I'm going to loosen this black screw ever so slightly and just manually move it up to a higher level. And then cinch it up so it stays in place. And then the same thing on this side. Loosen this black screw, manually move it up to about the same height as the other one. Very approximate is fine. And tighten it. And then what I'd like to do is to reinstall the cord grip. So the excess cable from here, I just gently stuff inside the box. Just screw back in the cord grip. Now you might have to loosen this black screw a little bit. That's just easy to get in. can see, 2 people is always easier to do this than 1 person. Great. So, in this case, thank you, George. In this case, we didn't have an awful lot of distance to travel. We just went from here to here, so the excess cord is not very significant. But in cases where you made a substantial change, you might have to go inside of the junction box. And then you might have to cinch up any excess material that is flopping around. And kind of coil it up. Ideally, you'd use something like zip tie to do that. So at this point, all the sensors have been leveled. They're at the height that you want them at. All the connections are made the way you want. The battery is connected, and you're essentially ready to turn on the instrument and see if it's going to work well.
Okay, so this is the very final step. We basically unpacked the unit, we assembled it, we made all of the electrical connection, we took it outside, we positioned it to the test area that we want to investigate, we leveled the legs, and everything is ready to go. So we just need to turn the unit on. We start by opening the control panel cover. We want to make sure that the solar power switch is on, and then to turn it on, well, and the step before is to make sure that the SD card is in place as well, and then we are going to turn the power switch on. One thing that I should say is that let's say if the unit's been traveling for a while and the battery maybe self-discharge a bit, what you can do is install the unit in place, turn on the solar panel switch, and leave the unit in over 24-hour period or something like that for the battery to recharge in case the battery is low. So we assume that our battery is in a good condition, and we are going to turn on the device and basically show you the startup sequence. Okay, at this point we are waiting for a few seconds for the screen to initialize. So SANTRI is starting. SD card is okay. Battery voltage is 13.35 volts, which is very good, and the software confirms that, and it says SANTRI running. And the next step is starting the GPS. We are outside here, and we should be getting a decent connection, and since we turned the instrument before here, our GPS is going to sync relatively quickly within a couple of minutes. When the instrument is taken far away from its last location, it is not surprising for GPS to take 15, 20, even 30 minutes for it to reacquire the GPS almanac and satellite locations and acquire the new location and date and time. Okay, so we can see on our display that right now it's already acquired the date and time, because the LCD is showing 2017 July 19 23 o'clock 5 minutes and 50 some seconds and counting. This is again GMT time that it's always using to record, and then user in the post-processing should adjust the time based on their location. What we can also see is the wind speed. So we have 0 wind speed, but when you turn on the instrument, you should basically spin up your wind vane manually to make sure that you are getting wind speed readings. Battery voltage again is about 13.35 volts, which is what you would expect for a well-charged battery. And this screen is updating every 1 second, and this gives us the most important information that we need for the instrument, which is that the battery is charged and that we are getting the wind speed readings and that date and time are correct. So the instruments are set up in such a way that the wind speed threshold at which the wind speed the saltation sensors are turned on is for this specific instrument set at 4.5 meters a second. So when our wind speed exceeds 4.5 meters a second, it basically starts the saltation sensors, and it basically starts to acquire the counts, and it bins the sizes of the saltation grains passing through the sensors. As you can see on the video, the LCD went into the sleep mode. So to wake it up, you would just press the LCD button, and you can see here that it is giving us reading. And we can also see that this time, in addition to wind speed and battery voltage, we are also getting a new line which shows us the signal average and the count information as the sensor is running. Because we don't have much wind here nor saltation, we are getting zeros. One thing to note is that the LCD refresh rate and our camera refresh rates are slightly different, so it seems like the LCD is continuously flickering, but when you are here and looking at it, it displays everything just fine. Okay, so kind of to repeat some of the things and to cover a little bit more detail is so when we install the instrument first, or we subsequently go to check on it, we would basically come to the instrument, open the cover, wake up the LCD screen and kind of look at the status, make sure the battery voltage is good, make sure that the wind speed is working properly, and that date and time are correct. And then the other thing that we would do is also spin up the wind speed sensor a little bit faster to go above 4.5 seconds threshold to basically check the operation of our saltation sensor. Because LCD is relatively small, we basically only display the data from the very first sensor. And what happens is when the threshold is exceeded, it takes about 10 to 12 seconds for the LCD screen to start reporting the saltation data. And what you see, once those 10 or 12 seconds are up, it starts updating the saltation data, and what you see on here are information for the first sensor, which is usually wired so that it's the lowest sensor to the ground. And we are basically seeing the first number is usually above 1000, and that's the signal average. And then the next number is the saturation count, which should be low, ideally 0. And the next number is the saltation counts and the sum of the saltation counts. And then we have the numbers counts for the next 4 bins. We are going to cover the data files and how data is recorded and what each field is in the next video. So this kind of covers the operation and maintenance of the instrument in the field. The way saltation sensor operation is controlled is by the wind speed. So when the wind speed exceeds the threshold of, in this case, 4.5 meters a second, the saltation sensors are turned on. And then the saltation sensors after that are running for 60 seconds. And if during that period the threshold is, every time the threshold is exceeded, that the instrument operates for the next 60 seconds and so on. All of the data is recorded on the SD card with 1 second resolution, and when you are finished running the instrument, all you have to do is basically shut off the instrument, and that closes writing to the SD card. And at that point, you can remove the SD card, download the data, and save that data. That's how you remove the card.